Our project title is Catapult Launches for UAV under the guidance of Mr. Surender G, Assistant Professor, Department of Aeronautical Engineering in Veltech University, and the students presented by D. Prapanchan, Anthony Cruz, and Kishore. And these are the title. And objective is to design and fabricate the UAV catapult launcher with bungee cord mechanism. And the table of contents here there, that is introduction, launching methods, about ARCO, project methodology, design and modeling, result and analysis, conclusion and reference. And introduction part coming to UAV launching system is a device used to launch an unmanned air vehicle a great distance without the aid of explosive device. And although the catapult has been used since ancient times, it has proven to be one of the most effective mechanisms during warfare. In the modern times, the term can apply to device ranging from a simple handheld implement to a mechanism of launching from a ship, land, a car, etc. And different means have been used to propel the catapult. These are US Navy is developing the use of electromagnetic aircraft launch system, the construction of Gerald Raffold class aircraft carrier. And these are the launching methods are there. There are 4 types: runway launch, catapult launch, and launch, balloon launch, which was introduced by the aircraft. And the components descriptions are there, that is cradle, rails, bungee cords are there. Cradle holds the UAV in position, is that part which also accelerates the UAV up the rail. And rail section is the backbone of the launcher structure. The front eye hooks which are used to attach the spring would transmit a load onto the rail, and thus a force is emanated inward through the front end of the rail. Bungee cord is also known as shock cord. It is an elastic cord composed of one or more elastic strands forming a core usually covered in a hover button or propellant sheet. And it gives the elastic for the cradle part. And research methodology, literature survey, preliminary data, design calculation, 3D modeling, fabrication, testing, analysis, and report generation. Here the literature surveys, we have taken the paper and give a statement for this papers. There are 15 papers out there: lightweight UAV launcher, pneumatic catapult launchers, and these are the papers visited. And preliminary data, we have included that pneumatic catapult launcher for this launcher type, manufacturer, rail length, maximum UAV weight, and maximum launch speed. And we have took for 15 launches out there, that is pneumatic catapult launcher, bungee catapult launcher, and bungee catapult launcher for high pressure. These are the things out there, datas. And the design calculation we did from this formula, that is K stiffness constant, bungee extension, coefficient of friction, V drag of force, mg weight of UAV, and lambda angle of elevation acceleration. And the force calculated by 110 Newton. And stiffness calculation also there in this formula we have did it. In this case, stiffness constant, E is Young's modulus of bungee cord, A0 is cross sectional area of bungee, L0 unstretched length of the bungee cord. Here the K stiffness is 75 Newton per meter. And stiffness calculation for under and end force, Newton force is, that is we have calculated here. The bungee stiffness table also given, that is force for 200 and 100, unstretched length, elongated length, stiffness constant, and Young's modulus also provided here. And these are the designing model, that is 3D modeling are there. In this view, the top view is generated, and this is the side view of this part of this cradle of this catapult launcher. And this is done by a software, that is CATIA model was presented here. The cradle section is here, and this is the structure of rail and span with the bungee. And we did the fabrication, the cradle fabrication, which is used by stainless steel of 2 mm thickness, and it is used by the design. The width of the cradle is 45 cm, and the width of the cradle with the wing section is 50 cm, and the wing holding section is made and mounted on cradle for the free release of the UAV. Ramp section is the backbone of the launcher structure. The front eye hooks which are used to attach the spring would transmit a load onto the rail. The ramp is of 3 meter, and the hollow aluminium is taken as a ramp. And bungee cord is a decreasing force, not a constant force. This means the UAV has a maximum stress initially but very low acceleration at the end of the rail. Usually these require 2 vehicles to pull the system to its initial position. This is the model we have did, and this is the working image and testing also there by the group members. And this is the conclusion. The report demonstrates the design engineering process involved in making an UAV launcher, and at last we generally generated our UAV catapult launcher with the model also. And the primary requirement with reliability being second from the primary concept size as the generator from which a final design was chosen. As is selected by bungee catapult mechanisms, the values for parameters such as bungee stiffness, extension, aerodynamic were determined. And the analysis of the CODA matrix showed the best merit design to be 56.25%, and a SolidWorks model is then built and a stress displacement analysis are performed. The lowest stress points such as minimize the weight and rack cradle were performed at the lowest stress points such as the assembly supports between ramp links were changed to cheaper lower weight PVCs. And generally at last we come to the conclusion part, that is we almost done this properly, and the reference were taken this paper, that is Austin Unmanned Aerial System, Novaquick, Francis Novaquick and Jen. We have taken from this reference. Thank you.